Hey guys, welcome back to the channel. In this video, we will discuss how to remove duplicates from a sorted list. So the problem statement says that given a sorted linked list, delete all duplicates such that each element appears only once. Now for this example, as we can see 1 and 3 have duplicates, so we need to remove that and return this as our answer. So let's see how we will solve this. As the list is sorted, then for every particular element, if it has a duplicate, then it has to be the adjacent element. Thus, we just need to compare the node and the next node. We take a pointer PTR which is pointing to head. The yellow arrow represents PTR's next. Thus, every time we have to compare PTR's and PTR's next value. And if these values are same, we will be performing this operation, which means that PTR's next will point to PTR's next to next, which basically means that we will remove the duplicate 1. And we will keep on doing this till we get duplicates. So let's try and understand with this example. So at first, we see that PTR and PTR's next value are same. So we will perform this operation. And now my PTR's next is pointing to PTR's next to next, that is to the node with the value 2. Now we will again check, and this time PTR and PTR's next value is not same, which means that all the duplicates of 1 has been removed. And now we will increment PTR by 1. Now here PTR and PTR's next value are not same, so we will not do anything and increment PTR by 1. Now PTR and PTR's next value are same, so we will perform this operation and now my PTR's next is pointing to null. In the next step, PTR also reaches to null, which means that we have found our answer and will return head. Now let's look at the code. We will be given with the head node of the linked list. We will declare a node pointer PTR which is pointing to head at first. Now the outer while loop will work until it reaches null, and in the inner while loop we are comparing PTR and PTR's next value, and if they are same we will be performing this operation. Note that for this inner while loop to work, both PTR and PTR's next should be available, and that's why we are checking for PTR next not to be null. We will keep on comparing until we remove all the duplicates of PTR value. Now when the inner loop will break, we will increment our PTR by 1, and finally when the PTR reaches null, we will return head as our answer. Let's try and run with this example. At first, PTR and PTR's next value are same, so the inner while loop will work, and PTR's next will now be pointing to PTR's next to next. Here again, PTR and PTR next value are same, thus the inner while loop will work one more time. And now my PTR next is pointing to the node with the value 3. Now as 1 and 3 are not equal, the inner while loop will break and my PTR will increment by 1. Now again we see that PTR and PTR's next value are same. Thus the inner while loop will work and PTR's next will now be pointing to null. As PTR's next has reached null, the inner while loop will break and the PTR will increment by 1, which makes it reach at null also. Here the outer loop will also break and we will return head as our answer, which is the list shown in the figure. Now the time complexity to solve this problem is O of n, as we are visiting every node only once, and the space complexity is O of 1 as we are using constant space. So this was all about the problem. Thank you for watching. Do like, share and subscribe to the channel for more such videos.